Welcome back. And we're now going to do our exploration, continue our exploration on electrostatic model. We looked at the model in the first section of the first video. We looked at the process of charging by conduction, direct contact with a charged object in the second video. In this third video, our final video in this series, we're going to look at charging an object by induction, by bringing in a charged object in the vicinity of an uncharged object and somehow charging that object. So let's begin our study of induction. So here I've brought a rubber rod rubbed with fur. So this is a highly negatively charged object with a fixed number of positive charges but excess negative charges near what was a neutral electroscope. And at the same time, I'm touching the top of the electroscope with my finger. We don't observe anything happening in the electroscope at all at this moment in time. The question now, though, is in this process, should I remove my finger next and then the rubber rod? Or should I remove the rubber rod first and then my finger? Well, we'd like you to think back from your conduction lab. We did a process towards the end of the conduction lab where we touched the electroscope with our finger and saw what happened. Keep that in mind as you look at the next query and then you think about what the answer to this question might be. As we continue the process of charging by induction, do we remove the finger first from the electroscope and then the rubber rod, or do we move the rubber rod first and then the finger? We'd like you to pause the movie at this moment. Again, we've shared with you before that research has shown that when students actually reflect on their own thinking and take intellectual risks, that they are much more likely to learn the material deeply and retain that material. So please take a moment, pause the movie, and make a prediction and provide reasoning for your prediction and your claim. We'll give you a moment to do that now. Well, welcome back, and I hope you've made a prediction either to remove my finger first or remove the rubber rod first. What we're going to do and take a look at the effects, we sometimes call this Nature Speaks. It's maybe a little artificial since I'm doing the experiment, but we will look at the results of the experiment. Nature will tell us what happens. So let's remove the rubber rod from the vicinity of the electroscope. My finger is still touching the electroscope, and now I will remove my finger. Nothing. No charge on the electroscope. So if this process is going to work at all, we have now learned from the experiment that we don't remove the rod first. We must have to remove our finger first. Removing the rod first just left your finger touching it, and we've learned in the last experiment, if I can remind you, that that's a method of grounding an electroscope. So we were left with a grounded electroscope had no charge. So let's try the other process. So here we are again, a rubber rod rubbed with fur, a highly negatively charged object brought near the top of an electroscope with a finger touching. And this time what we're going to do is, while I'm in this state, I'm now going to remove my finger from the electroscope, keeping the rubber rod still near but not touching. Let's see what happens. Okay, well, the electroscope is exhibiting some net charge. It could be just polarized. It still could be neutral, but polarized. We saw this in the last experiment, that as I was bringing the rubber rod near, that the lever arm would move away from the central arm because of a polarizing effect of the charges being separated from the top and the bottom. So something is going on here. It's a little better than we did before. Let's see if it's actually an excessive charge or just a polarization. So we'll remove the rubber rod now from the area. It definitely is charged electroscope. We charged the electroscope. Did you notice also that the lever arm is more has a greater angle? So whatever happened after I removed the rubber rod, in fact, the effect of the charging became more pronounced in the bottom of the electroscope. So we absolutely have a charged electroscope. We brought a rubber rod, just to review the process, near the top of a electroscope, a negative charged object, while we were touching the top of the electroscope with our finger. Remember, we then removed the finger, very important in our process, because if we did the other, we did not charge the electroscope. We removed the finger first, then the rubber rod, and we have a charged electroscope. The question is, how is it charged? We don't have an explanation for what happened yet. And we also don't know whether it's positively charged or negatively charged, and that's exactly what we would like you to think about next. So visualize the rubber rod brought near the top of the electroscope, your finger touching, removing the finger, then removing the rubber rod, resulting in a charged electroscope. We want you to conjecture on, did the electroscope acquire somehow an excess of positive charges to cause this repulsion, or an excess of negative charges to cause this repulsion? Again, please pause the movie. Think deeply about what you think is going on here. Go through each step in your mind. Visualize using the charged model what's happening with the electrons as they move, and make a prediction and provide a reasoning on whether you believe the electroscope is now positively charged or negatively charged. Pause the movie and make those predictions. We'll be back in a moment. All right, welcome back. Here's our charged electroscope, and we're going to do an exploration. We're going to do a little experiment to actually check a prediction of either a negatively charged electroscope or a positively charged electroscope. So let's move the electroscope out of the way and answer the following queries. And based on whether you indicated that the electroscope was charged negative or positive. So if you assume, when you look at this conjecture, you make the assumption either negative or positive. I'm going to say negative for the moment. So I'm going to say, what do you think would happen if we now brought a glass rod charged positively near the negatively charged electroscope? That's assuming it is negatively charged. I'm also going to conjecture, what do I think would happen if I brought a charged rubber rod near this negatively charged electroscope? However, if you instead thought the electroscope was positively charged, then what you should be answering is the conjecture, what do you think would happen if we now brought a glass rod charged positively near a positively charged electroscope? And again, what would happen if you brought a negatively charged rubber rod near this positively? So when you answer these conjectures, first make sure you've made a statement of whether you believe the electroscope is negatively charged or positively charged, and then answer the conjecture based on that initial condition. Pause the movie, reflect on these two queries, and then we'll get back together and test. Welcome back. And here's our electroscope with nothing near it. And we don't know yet whether it's positively charged or negatively charged, and we don't know how it got charged at all, in fact. But we will answer all these questions in the next few minutes. So I'm going to make the conjecture, since I had to do one or the other, that it's negatively charged. I'm basing that on the fact that I used a rubber rod. A rubber rod has a negative charge, so I'm conjecturing that somehow that rubber rod caused this electroscope to also acquire a negative charge. Now, that may be right or wrong. I'm going to do an experiment now to test that conjecture that the electroscope was charged negatively. So I'm bringing a glass rod charged positively near the top of this electroscope. It would attract negatives that are in this electroscope. So remember, I claimed that this electroscope is negatively charged, and that's what's keeping the lever arm away from the center arm, a repulsive force between them, both of these being negatively charged. If this positive charge is brought near the top of the electroscope, it should draw up negative charges towards the top, because unlikes attract, and the negatives that are down here should be attracted up towards the glass rod. But because there's a gap there and air is a very good insulator, the negative charges can't jump across to the charge rod. They would just be redistributed out from the bottom. Well, if I assume these were separated because they have a slight negative charge and I take some of that negative charge away, the lever arm should collapse. It in fact went further out, which refutes my original claim that this was a negatively charged electroscope. So even though I used a rubber rod to charge this electroscope, never touching it, we must conclude that the electroscope is charged positive. So let's make sure that this new realization that the electroscope must be positive is in agreement with our experiment. So if in fact the electroscope is positive, that means there's a deficit, a lacking or a missing number of negative charges down here. Remember, only the negative charges can move. So this is a positively charged center arm, positively charged lever arm because it's missing electrons. If I now bring the rubber rod here, more electrons are going to be brought up, and so more electrons are going to be missing, and this would be more positively charged, and we would expect the lever arm to be repelled by a greater angle, which is exactly what we see. So this is evidence that the conjecture now, the new conjecture that this is a positively charged electroscope, seems to be true. Let's just check it one last time by bringing the rubber rod near and see if that's consistent with a conjecture that this is a positively charged electroscope because it's missing electrons. Well, if we bring a rubber rod near the top charge negative, what it does is pushes electrons down into this area. Now remember what we said, this repulsion was because of missing electrons. If we now push negatives down here because like charges repel from the rubber rod, then we would expect that this would be less positive and it would collapse, which is exactly what it does. So we have, nature has spoken, we have excellent evidence that whatever happened to the electroscope, it definitely acquired a positive charge. So in this process of induction, now we can state that in this process of induction, that the charge acquired by the electroscope through this example is opposite to the charging object. We have one last thing to do. We need to actually figure out how that happened. All right, let's look at how that does happen. The electroscope was neutral at first, so there's an equal balance of positives and negatives. This is a conductor, so negatives can flow if they have a reason to flow. We have our rubber rod, which has a high degree of negative charges on it. There's still a lot of positive charges, but there's a great excess of negative charges, which if you remember, we got from rubbering it with fur. Now, my finger's attached, and my finger's a pretty good conductor, and what's happening is the negative charges that are in this electroscope are being repelled by the negative charges that are in this rubber rod, and they're looking for a way, because like charges repel, to get as far away from this rubber rod as possible, and so they escape out through my finger. The rubber rod actually is chasing electrons from the entire electroscope out through my finger. Now remember, if I remove the rubber rod next, they would just return to the electroscope, and that's our grounding process. But what we do now is we break the connection with my finger, which means those negative charges that escape through my finger do not have a pathway to get back. So the neutral electroscope, by bringing the rubber rod near it, chased the electrons out, like charges repel, negatives are mobile, out through my finger, and now breaking the attachment of my finger to the electroscope prevents them from returning when I remove the rod. And so the electroscope is missing electrons and has an overall deficit of electrons, which means an excess of positive over negative, and we have a positively charged electroscope. That is the process of induction. So once again, in a simple process of induction, the object being charged acquires an opposite charge to the charging object. Once again, we'll end the experiment by grounding out the electroscope. So in this case now, the negative charges return through my finger into the electroscope, balancing out the positives and negatives, producing a neutral electroscope once more. All right, so we've done our experiments on the electrostatic model. We reviewed the model. We reviewed conduction, a process of charging by direct contact with a charged object, and now a process of charging by indirect contact, often using a grounding or another object to charge our object. Let's answer some questions from our module. Go back to your module. We're done with the exploration. I hope you enjoyed it and learned from it, and we'll see you again soon. Bye-bye.